So, today we're doing the sum and differences of cubes. So this is kind of like in the last chapter, all the factoring we did to that where or no, not factoring. Systems. We did substitution elimination, graphing, all the stuff you did in Algebra 1, and then we did the 3 equations with 3 variables. That was new. Similar in this chapter. In this chapter so far, all the factoring we've done is stuff we did in Algebra 1. Now, if you remembered it and it was super easy, that's great. If you didn't remember it, that's why we went over it. But hopefully you guys are pretty solid now on some of that basic factoring stuff. But this is the first lesson you'll have that we are not doing from Algebra 1. So there's a couple things that we'll kind of talk about and jump around. First, really quickly, a review for a difference of squares. So the squares, it was a subtraction, it had to be subtraction, and those two numbers were perfect squares. So then we always, to factor this, we started by finding what my A and what my B are. My A is 1 number squared is 4, or 1 number times itself. Then to make 4x, 2x times 2x. And again, that makes sense. 2 squared is 4, and x squared is x squared. Then 49, that's 7. Once you have that, you use the formula, x plus 7 into x minus 7. The reason I start with that is because it's going to be very similar where we're finding our A and B. We find it a little bit differently, and then we plug into a different equation. But the big thing is finding A and B. There's one other part that I think is a little bit more difficult to remember. For the most part, if you can find your A and B, it's just plugging numbers into an equation. So, the other thing, the reason obviously, or hopefully obviously, if not, that's okay. The reason it's called difference of cubes is a exponent of 3. Just like 3 is cubed. Perfect exponents to the third. But this one, it doesn't matter whether you're adding or subtracting. So that's the nice thing about this one. You don't have to be super careful whether it's plus or minus. Either way, whether it's a sum or a difference, you can factor this way. Now, I gave you guys a whole list. I'm going to give you guys this on the test. These are all the perfect squares and perfect thirds. So if you see a number and you wonder if it's a perfect third, look to see if it's on your list. So if it's 216, it's on your list right here. And you can find out that that is 6 to the third. So 6 to the third is 216. If you see a number that's 500, that's not on here. So 500 is not a perfect third. If you see one that's 1,000, yes, 1,000's on here. That is 10 to the third. So that's how you use that chart. It also has the perfect squares in there as well. Those are more familiar to you guys, but they're on there. And I thought about not giving you this on the test, but the fact of the matter is, with a calculator, if you wanted to make that table, you could make it. It would take probably like 5 minutes. But you could just make that table if you really liked it. So rather than doing that, I'll just give you the table. You guys, again, you all could do it if you wanted to. So I'm going to give you that on the test. Last thing about this table, I want to 15, but it doesn't stop there. It keeps going. I've literally had people in the past that they get a number that's too big. They get a number that's like 5,000, and they say, well, Mr. Steffen, that's not a perfect cube because it's not on our chart. Well, yes, this chart only goes to 15. My apologies that I didn't have enough time to go to infinity. But I just went to 15 and I stopped there. So there probably won't be anything that's not on this chart, but just in case there's a number that's too big, you can either put the next couple rows or you can do trial and error, whichever works. To doing this, in my opinion, it's just 2 steps. The first step is find your A and B. That's why I can say these. So your A and B are just your first number and your last number. It's a little bit different than the quadratic formula. Oh, because we did it after the quadratic formula. All right, this is one that last year I did not do in this chapter, and now I'm moving it, so it's a little bit different. That's okay. Once you have your A and B, you're plugging those into your formula, or you're using SOFAs. Now, I always use the formula. If I was not going to give you the formula, I would definitely really try to harp on what SOFAs stand for. I'll go over it just in case that's something that interests you or if that helps you. I know Ms. Tobias, that's what she does. But again, I don't know if she actually gives you the formula. I'm going to give you the formula, so I would just use a formula. Last but not least, check your sign, and your answer, your sign should be the same, opposite, and then plus every single time. Same, opposite, plus. And we'll talk about what that means in a second. So to jump ahead a little bit, we're going to look at the formula, and then I'll go back to what SOFA stands for. So the a to the third and b to the third, again, just like with a perfect square or with the difference of squares, that just tells you it's a little map to find out what your a and b are. Once you have your a and b, your answer for this one is you're going to plug it into this second part of your equation. Now notice how I have it, and I didn't really know whether, I didn't know if this would make it more confusing or not. But it's hard because since it's a sum and difference of cubes, it could be a plus or minus here. It's minus, if it's a difference, it's minus. I put both those in there. But that means this could be a plus or minus. So I kind of used. This one then is the opposite. So if you had plus for the first one, you always use the top. So plus here means you have a plus here, which means you have a this one's always a plus. And if you have a minus at the beginning, you use the bottom. So minus here, and then plus here. The next one's always a plus. So first off, that's what I mean. When I'm looking at my answer, I'm looking at these signs, and those are the ones that I was talking about. When I said check your work and you should have same, opposite, plus every time, I'm talking about whichever sign you start with, this one should be the same, this one should be the opposite, and this one's always plus. So that's what I mean when I say check your signs, and I give you that same, opposite, plus. So what SOFAs does, and one of the reasons I don't like it is because it actually starts after you have this first part, which shouldn't be terrible to get a plus b, not bad, or a minus b. But then from here, we square the first. So once we have a, we square that front number. Then it's the opposite side over here. So whatever this sign is, it's always the opposite. So a times b times that. The next one's always positive, and the last one is the back squared. Square the back number. So yeah, that's a really nice way, in my opinion, if I wasn't going to give you the formula. But honestly, at this point, I'd rather give you the formula. But whichever way works is fine with me. One of the big things with the signs, I told you that they're the same, opposite, and always plus. These two signs will always be the opposite. So no matter what, if you want a really quick way to double check your work before you hand in your test, every single one of these, those have to be opposites. So let's go ahead and get started on one of these. So we have 8x to the third a minus b. Most of these were pretty familiar with you guys, square roots or squared numbers. Power is probably not as familiar with you. So go over to your chart or your table. That's the reason I gave it to you. Let's get rid of some of this stuff. And let's look for, our first one was 8. So is 8 a perfect cube? Yep, it's right here. What number to the third power is 8? You just go over to the left. That's 2. So if we go back down over here, ax to the third, my a is 2x. Because 2 to the third is 8, x to the third is x to the third. What about b is my 125? Again, go up to your table. 125 is right here. That is 5. So 5 to the third is 125. That gives you. We plug this number in. Use parentheses. So you have that up there. It's 2x. Since it's plus here, it's going to be plus. Then use parentheses. This is where a lot of people are going to make mistakes. 2x squared. This is plus, so we have a those are always opposite. 2x times 5 plus 5 squared. We will simplify that when we get back from lunch, but please make sure you're using parentheses. I'll tell you why in a second, because one of those is the hardest part that a lot of people miss. So, again, the biggest thing with this is I would definitely use parentheses for this, and the whole reason why is this 2x squared. If people don't use parentheses, most people mess this up and say that 2x squared is just 2x squared. and that's not right. You're squaring the whole thing, not just the x. That's why I always use parentheses. So the way your answer should look, x plus 5, then 2x squared, remember, both of them. So you square the 2 and the x, so it should be x squared minus, and then the rest of it should be 4. 2x times 5 is 10x, and 5 squared is 25. Again, not a bad idea to double check your signs. And the way, again, you can do said where we start with a plus, so it should be same, opposite, plus every single time. One really quick way some students do it is they just go through and double check to make sure these are opposite signs. Either way, that's one of the things people miss with this a lot is those signs. Whether they don't know how to do it or whether they just have to make those little things, that's a pretty common mistake. That's it. The whole lesson is doing that with different numbers, with different, probably not different variables, different signs. But that's basically today. Same problem, except for instead of a so your A is going to be the same. My A is 2x. 2x, my B is 5. So again, we have 2x minus 5. So now we start with a minus sign. Then we have 2x squared. And then the opposite sign, so we start with a minus, so we need a plus. Then we have 2x times 5 plus 5 squared. Now again, a lot of people then, once they have that, the next one's plus, they think the second one has to be minus. And again, that's always plus. This second one, no matter what it is, it's got to be plus. So again, this is exactly the same as the last one besides the signs. We have 4x squared plus 10x plus 25. And again, not to be a broken record, but the thing that people miss is 4x squared. Squared is different than 2x squared. And again, if it helps to look at both of those, how they're exactly the same, it just depends on what signs you start with. So moving on, number 4, the 729. Again, use your list. If for whatever reason you didn't have your list, you could always either take the third root or raise it to the 1/3 power or use trial and error. But you will have this on the test. 729 is 9 to the 3rd. So my A for this one is x. My B for this one is 9. X plus 9, since this is a plus, we start with plus. Multiplied by x squared minus 9, x squared minus, B is x times 9 plus 9 squared. Now this is one where you might be able to get away with not using parentheses for this one, but again, as you guys know about me, I would rather use time because it seems like there's some of you guys that as soon as you decide when you can and can't use parentheses or when you do and don't, you mess it up a little bit. So if you're super, that's on you. But I'm the same way because again, I think a lot of math is a lot easier if you just do it the same way every time. It may take a little bit more time or a little bit more writing, but that's okay. But again, that's like I said, that's all we're doing. In B, you plug it in. My next one with the number 5, my A is what to the 3rd is 27. You can use your list. That should be 3. And then x to the 3rd is x to the 3rd. Now this one gets a lot of people because they say, well, 1 is not a perfect third. Well, yeah, it is, because 1 times 1 times 1 is 1. So 1 is a perfect third. It's also a perfect square. That gets a lot of people on difference in squares. A lot of people see that and say it's prime. No, 1 is 1 squared is 1. 1 to the 3rd is 1. 1 to the 4th is 1. So those all fall into that category. And again, not to be broken record, but we do have, at the top, we have all those. So if you ever have 1, you can still do this. So we have 3x minus 1 because we're starting with a minus, which means we have 3x squared plus 3x times 1 plus 1 to the third, or sorry, 1 squared rather. So we have 3x minus 1, 9x squared plus 3x plus 1. Same thing every time. Two of them left, and then I'll have them do you do some on your own. This next one, now this goes up. That's okay. Just do it the exact same way as you normally would. What to the third is 8. That's 2. What to the third is 7. That's 9. X. 729x to the third. So the only difference is the B term. Again, harder than it is. That's just 2 plus 9x. Which means we have 2 minus a times b plus b squared. And definitely a place to use your parentheses. Minus 18x. Then you have 9x squared is 81x squared. That is, again, the most common mistake is people that just put 9x squared. Not a bad idea to go back and double check that when you're done if you have time on your test. This is definitely, I mean, the same story for all the other factoring problems we've done, in my opinion, is that they seem a little bit difficult, but once you start doing them, you realize you do the same thing every time. And once you've done enough of them, I will give you the formula, but it seems like once you've done enough of them, you kind of have it memorized anyways, because it's the same formula for all of these. We do the same thing every time. That obviously also helps if you do your worksheets and get all that practice. So the next one, now I will give you a heads up. This is not going to be on the test. It maybe is going to be extra credit. I don't know. Haven't decided yet. But 4 is not a perfect third. There's no number to the third power that's 4. So this one you need to factor a greatest common factor. I guess I should say it this way. There maybe is one like this on the test where you just take out a greatest common factor, because that should be one where if you don't know what else to do, or if nothing else works, it's not a difference in squares. It's not a sum of cubes. Factor. Before you put prime, 4, that leaves me with x to the third plus 864 divided by 4 is 216. So I guess I should say that maybe that part's on the test, but the fact that then the thing we have left is now a difference or a sum of cubes, so we can factor more, that's not going to show up on a test unless it's extra credit. Other factoring method is greatest common factor. That definitely will be somewhere, but that's back from section, I think it was 3. So from here, we have x, my b, 216. Again, if you need to go look, 216 is 6 to the third. My b is 6. With x plus 6 times x squared minus x times 6 plus 6 squared. X squared minus 6x plus 36. But don't forget this, that still means nothing. So what we have in green right here, that's just this part. That does not include the 4. So you need to remember that 4 has to go in front. Like I said, don't bang your head against the wall with that too much. It'd be a great extra credit question, but I'm not going to have any on the test where you have to do that. After one thing out, and then or a difference after that, that's not going to happen. All right. Go ahead and do those next ones on your own. I'll put the answers up in a second. All right, so my answers are up there if you want to check those. Again, hopefully it's not too bad. You're just plugging the same, you're plugging numbers into the same equation. Just be careful. Like I said, that's why I wouldn't skip steps, because this way you can do it the same way every time. And again, number 12, if you struggle with that, we will not have ones like number 12 where you factor out a 2 or factor something out and then you have a difference of cubes. But obviously you do need to know, if you can't do anything, to look for a greatest common factor. If you have any questions, let me know. Other than that, I would do the worksheet and then work on your exit ticket, or your homework check, rather.